All right. Now let's talk about dual alternative decisions. Okay. So in case of in case of uh, the previous single alternative decision, it was from the uh, from the condition you had a detour, right? You had a single detour, and otherwise you came back to the same point. Came back to the same point before we keep on executing, right? But in case of dual alternative decisions, you actually the decision can take you two ways before you join. Okay, so it's like a fork. It's like a fork which eventually joins. So it's not like a detour, but it's a fork which eventually joins the main code. Okay, but the two paths can be separate. The two paths are completely separate. Okay, so let's see how it actually looks like. So if you had to draw the execution, right, of a program with a dual alternative decision, it would look like this. So let's say you execute statement one, line one, right, line two, uh, line three, and at line four you make a decision. You try, or you have to make a decision, okay, based on some condition. Now, if that condition is true, that condition can be true, right? The condition is true, then you execute line five, and maybe line six, line five and line six, okay. And if that condition is false, if that condition is false, you execute lines, you execute lines, say 8 and 9. And then eventually you join. Eventually you join. Okay. So, sorry, 10. Okay. And then you carry on, 11, and so on and so forth. Okay. So as you can see, it's a fork, right? It's a fork at this place. Fork. And it's called dual alternative because this decision can take you either this path or this path, right? So there are two ways you can go. Okay. Sometimes what tends to happen is often these paths do not join, and that's completely okay. By the way, that's okay with single alternative decisions as well. So I'll show you an example of, not example, but a representation, a diagram of what I mean. Okay. So you can execute statement one and two, right? And at three, you make a decision, right? And that decision will take you either to four, five, and then stop the program, or it can take you to 7, 8, and then stop the program. So the paths never join. That is perfectly acceptable. Okay. Similarly, in the single alternative decision, let me go back a little bit. So you can have one, you can have two, right? And then at three, you make a decision. And based on that decision, you go to four and then stop the program. So it's not always necessary for the path to continue after the decision. Okay, it may, or there may or may not be a path. Okay, so in this case, you execute one and two regardless of that condition, and if that condition is true, you additionally execute statement four, but then you stop. Okay, and if that condition is false, you stop at one and two. That's it. Okay, so it's not necessary for these paths to join. Okay, this is a valid path. This is also a valid path. Okay. Now, the dual alternative decisions uh, are taken with the else keyword. Okay, so it's just like English, right? So if this is true, do this, else do this. If, else, just like English, right? So if this condition is true, execute this statement or block of statements, else execute this statement and this block of statements. And once you're done with that condition, if you want to join, you can join here. Okay. Now, again, remember this, that these need to be indented, right? So let me clear this. So you see this, there is an indentation. There is a tab or a space. Okay? There is an indentation here as well. Okay. Any line that is indented after the if statement is considered to be part of this if block. Okay. If block. Similarly, any line that is indented after this else would be considered part of the else block, right? Else block. Okay.